This is the moment every software engineer dreads. You have spent months, maybe years, building your system. Users finally start pouring in, and suddenly, everything begins to choke. Latency skyrockets. Requests start failing. Your CPU dashboard is glowing bright red at 100% utilization. The logs are flooded with connection timeout and 503 service unavailable errors. At that exact moment, you are faced with one of the most important decisions a solution architect will ever make. Your system needs to scale, but you have to choose the right path. Welcome to another system design capsule. Today we are not talking about code. We are talking about engineering a system that can survive the next million users. Today's battle is legendary: vertical scaling versus horizontal scaling. When should you buy a bigger server, and when should you buy more servers? Let's start with the most obvious solution, the one almost every beginner chooses. Vertical scaling, also known as scale-up. The concept could not be simpler. You have one application running on one server, and that server is overloaded. So you call your cloud provider and say, "Give me a bigger machine. Instead of 4 CPU cores and 8 GB of RAM, upgrade it to 16 cores and 32 GB of RAM." Sounds perfect, right? Here are the advantages. Extreme simplicity: you do not have to change a single line of code. The same application that ran on the small server will continue running on the larger one. Simple architecture: no load balancer. No distributed systems. No additional operational complexity. But why is this a trap for systems that need serious growth? Hardware limits: motherboards, CPUs, and RAM all have physical limits. There is no server with infinite resources. Exploding costs: doubling a server from 8 GB to 16 GB may be affordable. But upgrading from 128 GB to 256 GB of RAM? That becomes incredibly expensive. High-end hardware comes with premium pricing. Maintenance downtime: hardware upgrades usually require rebooting the server, meaning your system becomes unavailable during the upgrade. Most importantly, single point of failure (SPOF). If that giant server, the one you've invested thousands of dollars in, crashes because of a software bug or a data center outage, your entire system goes offline instantly. This is where real architectural thinking begins. Horizontal scaling, also known as scale-out. Instead of buying one gigantic server, you buy many small, inexpensive servers and let them work together. Then you place a load balancer in front of them to distribute incoming traffic. Why is this approach so powerful? Virtually unlimited scalability: need more capacity? Add a fourth server, a fifth, 10, 100. There is no practical ceiling. Cloud providers even offer auto-scaling, where new servers are created automatically as traffic increases. High availability and fault tolerance: this is the biggest advantage. If server number 2 crashes or its motherboard fails, the load balancer immediately stops sending traffic to it and redirects users to the remaining healthy servers. Your application stays online. Elastic cost efficiency: traffic drops overnight? Simply remove unnecessary servers and stop paying for them. But there is a catch. A very expensive catch. Not expensive in hardware. Expensive in architecture. To make all these servers work together, your application must be redesigned. Your application must become stateless, meaning it cannot store user sessions in server memory. You need a proper N-tier architecture using technologies like Redis or another centralized data store to manage application state. Let us dive into the part where most junior engineers struggle. Have you ever been shopping online, added items to your cart, and suddenly saw an error? You refresh the page. The website comes back. But your shopping cart is empty. Why? Because your cart was stored inside the memory of the server that just crashed. When the load balancer redirected you to another server, that new server had absolutely no idea who you were. That is why, in horizontal scaling, storing application state inside server memory is forbidden. So what is the solution? Option 1. Sticky sessions. Configure the load balancer to always send the same user to the same server. It works until that server crashes. Then you are back to square one. Option 2. The architectural solution. Use a centralized state store such as Redis. Whenever the application wants to save a shopping cart or a user session, it stores it in Redis. Now, if one server dies, the next server simply retrieves the user's data from Redis. The user never notices the failure. Of course, that is only the beginning. Now your database has to handle 50 application servers writing simultaneously. That is where concepts like database replication and database sharding enter the picture, topics we'll cover in future capsules. Here is today's engineering takeaway. Scaling decisions in large companies are never black and white. They are always about trade-offs. If you rely entirely on vertical scaling, you will eventually build a gigantic dinosaur of a server. Powerful, but if it dies, your entire company goes down with it. On the other hand, if you push horizontal scaling to the extreme and deploy 1,000 tiny underpowered servers, the operating system and the network will consume a huge portion of your resources. Your servers will spend more time talking to each other than serving your users. That is why experienced architects almost always choose a hybrid approach. They do not build dinosaurs, and they do not build ant colonies. They build a battalion of tanks. First, they scale up each server enough to handle serious workloads, for example, a machine with 16 CPU cores and 32 GB of RAM. Then they scale out by deploying 5 or 10 identical servers behind a load balancer. Now you have powerful servers that process requests efficiently without excessive network chatter. And if one tank loses its engine, the other 9 keep fighting. Your system stays online. That is the real goal of modern architecture. If this capsule helped organize your thinking, do not forget to like the video. Subscribe to the channel so you never miss the next one. See you in the next capsule. Thanks for watching.